Hey everyone, in the previous video we discussed the first 5 arithmetic operators. Now let's continue with the remaining 2. Next we have modulus or remainder, which is represented with this percentage symbol. So let's take this example 23 modulus 4. Now how many times 4 divides 23 completely? It is 5 times, right? Because 4 multiplied by 5 will be 20. But if you multiply with 6, it will be 24. It will exceed 23. So it can divide 23 completely 5 times. So 4 5s are 20. And what is the remainder to make it 23? It is 3, right? So the remainder is 3. Or you can also follow this kind of division method, like 4 5s are 20 and the remainder will be 3. All right. And in this example, the only difference is instead of 23, we have 23.0. So we have at least one of the operands as float. So your result will be a float value. So we'll get 3.0 in this case. And in the next example, we have 23.2 modulus 4.2. Now 4.2 multiplied by 5 will be 21.0, right? So what will be the remainder? It will be 2.2. Right? So 23.2 modulus 4.2 will be 2.2. I have added all those examples here. Now let's run this program and verify. Right click, run, and this is the output. Now if you see the output, in the first 2 examples we got what we expected, 3 and 3.0. But in the last example, we expected the value to be 2.2. But we got something like 2.19999 so on 84. And this should not surprise you now, because we know that when it comes to floating point operations, we might not always get the exact result. We might get something close to the expected value. So we expected 2.2, but we got something close to 2.2, but not exact value. So whenever you expect the output to be a floating point value, you should always keep in your mind that you might not get the exact value. Now the last operator is power or exponent, which is represented by this double star operator. Now if you see this example 2 double star 3, this is nothing but 2 power 3, which will be 8. Now if you take this example, here we have 2.0 power 3, right? One of the operands is float, so obviously your result will be float. So we'll get 8.0 in this case. Now let's see the last example 4 double star minus 2. We already discussed about this in the beginning, right? So here we don't have any float value in the expression, but still we'll be getting a floating point value, because when the exponent is negative, 4 power minus 2 will be nothing but 1 by 4 square, which will result in a floating point value. Now let's verify all these examples. So let me run this program, right click, run. So you can see the outputs for these expressions here. 8, 8.0 and 0.0625. Now that we completed all the 7 arithmetic operators, let's also discuss about augmented assignment operators, because they are also kind of related to arithmetic operators. So generally when we assign a value to a variable, we use this kind of a syntax, right? A is equal to 5. Augmented assignment is nothing but we associate some sort of an operator along with assignment. So when you write a plus is equal to 5, this is nothing but a is equal to a plus 5. A value is 5, right? So this will evaluate to 10. So now a value becomes 10. Similarly, if you see the next line, here we have a star is equal to 10. This is nothing but a is equal to a star 10. So a value is 10 at this point. So this will become 10 star 10 100. So now a will become 100. Not just addition and multiplication, in the same way we can use other arithmetic and bitwise operators as well. In the next tutorial we are going to learn about bitwise operators. So we can use these operators along with assignment in this manner. Now let's see this example in action. So here we have a variable a, we are assigning value 10 to it, and we are printing the value of this variable. Next, in the next line, we are using a plus is equal to 5, which is nothing but a is equal to a plus 5. As a value is 10, so this will become 15. So here when you try to print a, it will print 15. In the next line we have a star is equal to 5. This is nothing but a is equal to a star 5. What is the value of a? A value is 15, right, till this point. So this will become 15 star 5, 75. So when you try to print a, it should print 75. Let's run this program and see. Right click, run. And as you can see, initially the value of a is 10, so it prints 10. Next it becomes 10 plus 5, 15, so it prints 15. And at this point a becomes 15 star 5, 75, so it prints 75. Now let me tell you one thing before closing this video. So in all these examples we directly used these values in the expressions, right? And we are putting these expressions inside print functions. But generally when we write real-time programs, we should be using proper variables. Like in this manner, instead of directly using the values, we can create variables like these, and we can even create variables for the output of expressions. This makes your code much more meaningful, and whenever someone reads your code, it will be much easier to understand what's happening inside your code. And also in the variables tutorial, we clearly discussed the advantages of using variables and the amount of flexibility variables offer, isn't it? So when we write real-time programs, we should always try to use proper variables. All right. With this, I hope you understood how arithmetic operators work in Python. Next, we are going to discuss about bitwise operators. I'll see you in the next video.